Constructing and interpreting functions. In this
Objective.
lesson, you will construct and interpret functions given in verbal descriptions, two coordinate values, tables, or a graph.
Vicky charged her phone's battery to 100%. Then she took the phone off the charger. When her phone is off the charger, it loses 5% of its total battery life every hour. We can use functions to model these types of situations. Functions can answer vital questions such as, when will Vicky's phone run out of power? And after 5 hours, how much longer will the phone have power? We can create an equation for a linear function from its verbal description, table, graph, or 2 points. In this lesson, we will create equations for linear functions and interpret them in terms of the situations they model.
Functions and verbal descriptions. In the introduction, Vicky's situation was represented in a verbal description. To create a function from a verbal description, we need to determine 3 values. 1. Identify the independent x variable, quantity, and the dependent y variable, quantity. 2. Determine the rate at which the function's y value changes with respect to a change of 1 unit in the x value. In other words, find the rate of change. 3. Determine the initial value. That is, find the y value when the x value is 0. The rate of change in the initial value can have a positive or a negative sign. So, it is important to check the sign when determining these values.
I saw the sign, opened up my eyes, I saw the sign. So, in this activity, we are going to read the instructions. We're going to type in our response. Okay, here's the activity. In this activity, you will create an equation for a function represented by a verbal description. Vicky charged her phone's battery to 100%. Then she took the phone off the charger. When her phone is off the charger, it loses 5% of its battery life every hour. What function models the percentage of battery life in terms of the number of hours since Vicky took it off the charger? First, we need to identify the independent and dependent quantities from the function's verbal description. What is the independent quantity and which variable should it represent? Identify the independent and dependent quantities from the function's verbal description. The independent, the part that is changed, is the number of hours that the phone is off the charger. The dependent, or the part that changes as a result of changes made by the independent variable, I have a typo, the percentage of battery life after the time off the charger. So, how long is it off the charger? That could vary. Maybe it takes an hour to get home. Maybe it takes 5 hours to get home to put the phone back on the charger. The dependent is how much percentage of battery life is left depending on how long it was off the charger. What is the independent quantity and which variable should represent it? The number of hours off the charger. It could be H for hours, but usually an unknown or independent variable is represented by X. So that is the quantity, the independent quantity is X, the hours off the charger. Part B, what is the dependent quantity and which variable should represent it? The percent of battery left. Which variable should represent it? B for battery life. So they say that the percentage of battery left in hours is the dependent quality. So the variable Y should represent it. The y goes at the beginning of our equation, and I have to get that straight in my head, that B doesn't stand for battery life. Y is the variable for battery life. My mistake. What is the initial value of the function? Is it positive or negative? Explain your answer. The initial value is 100%, as 0 time has passed. Therefore, the function is positive. What is the function's rate of change? Is it positive or negative? Explain your answer. The rate of change is minus 5% per hour. It is negative because it is a decrease from the initial value. What is the equation of the function that models the phone's remaining battery life in terms of the number of hours from the time Vicky took her phone off the charger? So the rate of change, remember slope, we just did a thing on slope, of the function m is minus 5. And the initial value of the function b is 100. Remember, the b at the end represents the point where the y-intercept is. So 100 is the point where the y-intercept is. So for example, on the chart, all the way up at 100 would be, or on the graph, I'm sorry, all the way up at 100 is where the line would start and crossing the y-axis at 100. That is why we cannot use B for battery life. It screws this up. The y here is the battery life remaining after minus 5% per hour plus the original 100. So the equation is y equals m times x plus b, or rather the y variable equals the slope times the independent variable plus the y-intercept. So that is y equals minus 5 multiplied by x, or the independent variable, plus 100. Self-evaluation. I'm still a little fuzzy of what is meant by function. That was a little weird for me.
Let's write another function based on its verbal description. A company owns a network of family campgrounds. The company charges an annual membership fee of $600 per member. In addition, each member must pay $5 per night in camping fees. What function represents the total fees that a member pays in year in terms of the number of nights camped? To find a function, we first need to identify the independent and dependent quantities involved. That is, we need to identify the x variable and the y variable in the function. In this situation, the number of nights a member stays at the campground is the independent quantity. It is based on the number of nights stayed. So, we represent these nights with the x variable. The total fees paid by the member are the dependent quantity. So, we represent them with the y variable. Next, we need to find the rate of change of the function. Here, the camping fee of $5 per night is the change in total fees a member pays per night of camping. So, 5 is the rate of change of the function. Finally, we need to determine the initial value of the function. In this situation, the annual membership fee of $600 corresponds to 0 nights of camping. That is, $600 is the initial cost for being a member before any camping. So, 600 is the initial value of the function. By following this 3-step process, we can easily create the function that represents the situation. Notice that in this example, both the rate of change and the initial value are positive. The rate of change is positive because the amount the member pays increases as the number of nights camped increases. The initial value is positive because it represents how much the member pays before camping. Now let's substitute the initial value and the rate of change into the equation for a linear function, y equals mx plus b. The initial value, b, is 600, and the rate of change, m, is 5. So the following function models the amount paid by a member in terms of the number of nights camped in a year. Y equals 5x plus 600. We've written a function from its verbal description. However, a function isn't worth much without knowing how to interpret it. Now, suppose we have a function and a situation. How can we interpret the function in terms of the situation? The first aspects of the function we need to identify are the independent and dependent quantities in the situation. Knowing the relationship of the two variables in the function will give us a better understanding of what the function is saying. Then, we note the function's rate of change and initial value. The rate of change is the change in the dependent quantity, with every change of 1 unit in the independent quantity. The initial value is the dependent quantity's value when the independent quantity is 0. Using this information, we can interpret the function in terms of the given situation.
Interpreting a function. This is the lesson activity, interpreting a function. Bottom of page 2 of your guided notes. So in this activity, you will interpret a function in terms of a situation. Steven's cat drinks from a bowl. The following function represents the ounces of water left in the bowl in terms of hours since it was filled. Y equals negative half times x plus 4. So what do all those parts mean? To interpret this function, first determine which variable represents which quantity in the situation. In the equation, x represents the independent variable. That is, and y represents the dependent variable. The question is, which variable represents the ounces of water left in the bowl? X represents the independent variable, which is the number of hours since the bowl was filled. Y represents the dependent variable, how many ounces of water left in the bowl. So the answer is the Y variable. Now part B. Which variable represents the number of hours since the bowl was filled? We just answered that question up here. Where'd it go? I don't know. That's the X variable. It represents the independent variable, which is the number of hours since the bowl was filled. Part C. Now that you have the dependent and independent variables, you need to determine the significance of the values in the function in terms of the situation. What does that mean? That means I can look at an equation like this, or a function like y equals half times x, or negative half times x plus 4, and not have a clue what the heck that's talking about. So we got to be able to plug in the parts so we know based on the situation what it's covering. It's one of the hardest parts about math. So, there's my answer. I don't know where it went. So, what does the 4 value represent? The 4 is the number of ounces of water in the bowl when it's first filled. I know that because plus B is the position that the plus 4 is in, and that represents the starting point, or the y-intercept. The starting point must be 4 ounces as filled before we even start. What does the half represent? The value half represents the rate, the change, or the rate of change, also known as slope, in ounces in the bowl every hour. So every hour we lose half an ounce. How did we do? I think I'm starting to get it.
A linear function's equation always has two. We can
gets
write
me every
any
time.
linear function in either form shown in the image. Note that in both forms, m, the coefficient of x, is the rate of change, and b, the constant, is the initial value for the function. We can interpret a function by comparing it with the general equation for a linear function. Look at the image. The value in the function that corresponds to m is the function's rate of change, and the value in the function that corresponds to b is the initial value. This gives the function's rate of change as -1/2, and its initial value is 4.
And that color coding is something that I try to do in the activities as we go further, because it's important to practice substituting these parts. They go in the same spots every time. So we're given this function, and then we are able to substitute the information to be able to solve for the parts that are unknown.
A linear function's equation always has two terms, a term with the x variable and a constant. The order of these two terms isn't important, so the two functions seen here are equivalent. In each function, -1/2 is the unit rate, and 4 is the initial value.
Question. Select all the correct answers. The function represents the cost in dollars of playing video games in terms of time spent playing in months. So what they want us to do is look at this equation or this function and think about the parts in terms of rate of change and initial cost. So I'm going to use the highlighter tool and say that the initial cost, it costs $45 a month, or the initial cost is $45. Let me try again here. There is an initial cost of $45 to play the game. So let's say you buy Fortnite. I know it's free, but you buy it. It costs $45 before you can even start playing. Then, so that's the $45 there. Oh, they're not going to let me highlight it. Dang it. So that's a $45 here. Let me see if I can go back
A linear function
and try it again. So $45 green is the $45 initial cost to play the game. Then from that spot, every month it goes up $15. This is the $15 per month. It costs $15 per month to play the video game. The months, the number of months that you play the game before it's boring or everybody's playing it, is the X right here. The total cost of playing the game is dependent on how many months you play it. So the total cost is Y. So the Y variable represents the cost in dollars, and the X variable represents the number of months. There you go. Those are the three parts. Basically, think of it as step 1, find the rate. Step 2, find the y-intercept. And step 3, solve for the y variable and the x variable. The identifying of these is the first step. I'm sorry. I misspoke. First, identify what's what. All right, now we can move on. don't know why that's there. It's kind of weird. I need to go back on this one. Here we go.
Rick's Garage, since 1977. My father opened this garage when I was 5 years old. He named it after me. So that's why it makes me proud that Rick's Garage is renowned for two things: fixing cars and making graphs. I know what you're thinking. What do graphs have to do with fixing cars? Well, don't take it from me. Listen to a satisfied customer.
I needed a new serpentine belt. I came to Rick's Garage because a friend referred me, but I was a little skeptical. Rick couldn't quote me a price on the repair up front because he wasn't sure how much labor would be involved. He anticipated somewhere between 1 and 2 hours of work for my car. Again, I was a little concerned, but then Rick started making a graph.
The cost of auto repair can be scary, but I wanted to put Dina at ease. This graph represents the total cost of the repair along the y-axis and the number of hours of labor on the x-axis.
In the last example about the video games, what was it, $45 to start playing? The initial cost, that would have been right here at 40, just above the 40 mark.
The serpentine belt costs $40, so $40 is our initial value. That's why the y-intercept is located here, at the $40 point. Now that I've told Dina the initial value, I need to give her the rate of change. To find that, I need to find the slope of the line on the graph. The rise is 80, and the run is 1. Now Dina knows that the rate of change is $80 per hour.
Whereas the rate of change for the video game was $15 per month.
That's when Rick and his graph made sense of everything. With a rate of change and an initial value, he wrote a linear function. Even though he couldn't give me a final price on my repairs, the linear function and graph allowed me to estimate the cost based on the number of hours it takes to perform the maintenance. Thanks, Rick.
My pleasure. Because here at Rick's Garage, you can count on two things to give you peace of mind: a car that's as good as new and a comforting graph. That's the Rick's guarantee.
The video showed how to create the equation for a function from a graph. We had a graph that represented a function. From the graph, we found the x and y variables for the function. So, we only had to determine the rate of change and the initial value of the function in the graph. After that, we could easily get the function by substituting these values in the equation, y equals mx plus b. We can also relate a graphed function to a situation.
All right, lesson activity, slide 17. This is the activity for Chris has a clogged drain. So, in this activity, you will interpret a function represented in a graph. Chris has a clogged drain in his kitchen. The graph represents how much it will cost Chris to get it fixed in terms of the number of hours the plumber works. So if we just look at the graph, 40 is on there, and then I see it goes over 1 for an hour worked, and the rise is from 40 to 80. So the rise appears to be from 80 to 120. It seems to be $40 per hour. So initial cost of 40 and $40 per hour. First, identify the initial value and its significance in terms of the situation. So the initial value is $40. That's how much it costs just to get the plumber out. What does the initial value represent? $40 just to get the plumber to show up. That's the just the call him out to the job site price before any time has been spent working. Then next, identify the rate of change and its significance in terms of the situation. What is the rate of change of the function graphed? So we identify the rate of change and its significance. What is the rate of change of the function graph? Well, rise is 40, run is 1, 40 over 1. So the rate of change, or the slope, is the change in y over the change in x. Remember, the change in y is y2. So this is y2 minus y1. So 80, right here, 80 minus 40 equals 40. And remember, the rate of change is change in y over the change in x. So the change in x is x2 minus x1. So x2 right here is 1 minus 0 is 1. It can be done the same way. Up here, I could say x is 2 minus 1 is still 1. So 40 over 1 equals 40. The rate of change is 40. That means the slope is 40. That means in the formula, wherever it is, for the function, it is the m, or the slope. What does the rate of change represent in this situation? In terms of the situation, the rate of change represents the cost each hour that the plumber works, aka the cost of the labor. Self-evaluation. I think I get it.
So far, we've created an equation and interpreted a function from a graph. We just need to determine the slope and the y-intercept to create the equation of a function. On a graph, the slope represents the function's rate of change, and the y-intercept represents the function's initial value. We can interpret these values of the function in terms of the situation, but we don't need the whole graph of a linear function to create an equation. We can create an equation and interpret a linear function if we know any 2 points that satisfy it.
All right. This activity, function from 2 points, is the bottom of page 2 in your guided notes. Activity. In this activity, you will create a function from 2 points that satisfy it. So we are looking at the 2 points on the graph and making this function out of that. How do we do that? So a linear function passes through the points -2, 3, and -3, 5. Complete the following task to find the equation of the function. To find the equation, first find the rate of change. What is the rate of change for the linear function that passes through the 2 points? So given these 2 points, -2, 3 and -3, 5, we can then find the slope, or the rate of change. Remember, y2 minus y1 over x2 minus x1. We just did this. So 5, 3, which is this 5 over this 3. So y2 minus y1. So 5 minus 3 over -3 minus -2. So this -3 minus this -2. That is this. When you do that math, 5 minus 3 is 2. -3 minus 2 equals -1. Hey Siri, what is -3 minus -2?
-3 minus -2 is -1.
My phone said it, not my watch, so it was a little bit quiet. But trust me, That's how you get it. If you don't know for sure, please use a calculator until it looks right. Okay, so 2 over -1 equals -2. Part B, using the rate of change, so we just got the rate of change, it's -2, to find the function's initial value. That's where B is. Remember, I can't use B for battery life because B is the initial value. So substitute the rate of change you found and the values of one of the points into the equation y equals mx plus b. What equation do you get? So we substitute the rate of change and the values of one of the points into the equation. So here's the equation, y equals mx plus b. So the first point is -2, 3. So we substitute that in. So the slope is -2. It's this bluish green color, and we substituted that in. And the coordinates of -2 and 3 into the equation. So -2 is the number of hours, or the x-axis, and the number, and y is 3. It is the y point. See? All color-coded. That one's not for some reason. So we get 3 equals -2 multiplied by -2 plus b. The answer key, I believe, is incorrect. The example down below reflects what is here above. The key shows the 0.5 comma -3 or -3 under this one. So just when we're grading and or looking at that, it's best to keep it straight. And I believe the answer key in the guided notes is incorrect per down below. So moving on to the second point. The second point is 5, -3. And the slope is still -2. We already figured that out. So the 5 is the y, and the -3 is the x. The -2 is the slope, and b is the initial point. Remember, we're trying to find the initial point. So we've got the rate of change is the slope. I don't know where that went, but the rate of change is the slope. We've got the 2 points. And we have now figured out the equation for the second point. So the equation is either 3 equals -2 times 2 plus b, or 5 equals -2 times -3 plus b. Guess what? Part C is now use your equations from part B to solve for the value of this lowercase b. So we do that just like we've done equations in the linear equation problems or the equivalent equations, where we now have an equation and we go through the steps of solving it. First step is -2 times -2 equals +4. If I owe -$2 and I multiply that by -2, I can explain later on how a negative times a negative is a positive, but basically you're looking at -2 things times negative 2 things equals a total of 4 things, or 4 things in a group, even though these are negative. I'll explain later. Just ask me. So 3 equals 4 plus b. Remember what we do to one side of the equation to get the variable by itself, we do to the other side of the equation. So we get rid of this 4 to get the variable by itself. 4 minus 4 zeroes that out. That's why there's no number here. 3 minus 4, what we do to one side, we have to do to the other. 3 minus 4 is negative 1. So b equals negative 1 for part C. Now we go through the process again for the second equation. 5 equals negative 2 times negative 3 plus b. So, for same thing. Negative times a negative is a positive. Negative 2 times negative 3 is 6. So we now have 5 equals 6 plus b. What we do to one side, we do to the other. So we take away this 6 from both sides. 5 minus 6 is negative 1 equals b. Those match. Awesome. Part D, finally use the rate of change, m, and the initial value, b, to create the function. Write the equation of the function that passes through the 2 points. So, the rate of change, or m, which is slope, is negative 2. The initial value, b, is negative 1. That's the y-intercept. To create the function, write the equation of the function that passes through the 2 points. Phew. So, using our standard equation here, our function for a line, y equals mx plus b. The plus b is written as minus 1 because b equals minus 1. Just wanted to clarify how we got from positive to negative here. Adding a negative is the same as subtracting. So y equals negative 2 times x minus 1. Self-evaluation. That got confusing at the end, keeping all the parts straight. Moving on.
If the slope is 0,
Oh,
then
crud.
the lesson
Here we
activity
go.
showed that we can find a function from 2 points. Sometimes coordinates describe 2 points. At other times, a table may represent the 2 points. In either case, we use the same method to find the equation for a function.
So if you were given this table, or if you were to use the math tools and the graph, and then add the data, this is the table. So those points, whatever they were there, negative 3 and 5, or sorry, 5, negative 3, and negative 2, and negative 1, whatever they were, you would put them on this table. Sorry, that was a little confusing. Oh, negative 2 and 3, negative 5, sorry, negative 3 and 5. You'd put those on the table.
So far in this lesson, we've seen only functions with a non-zero rate of change and a non-zero initial value. However, there are functions where either the initial value or the rate of change may be 0. Functions where the initial value is 0 represent proportional relationships. On a graph, a line passing through the origin represents a function that is a proportional relationship. This function has the equation y equals mx. If the slope is 0, then the y value stays the same regardless of the x value. Such functions are constant functions. The graph and equation shown here represent a constant function. Notice that a graph of a constant function is a horizontal line that passes through the y-intercept, b. Its equation is y equals b, where b is a constant.
All right. So for this question, it says drag the tiles to the correct boxes to complete the pairs. I need to pause so I can show how I did this. Even though it's not on your notes, this is very likely a mastery test question. This is the type of question they like to ask. So let me walk you through it. So we have these tiles or the tables, and there are 3 different tables. And they want us to interpret this data and determine which of these functions this data represents. So let's show how I do that in steps. So we are given these 3 tiles or tables of information. And X is 3 and Y is -2. X2 is 1, Y2 is 1. X1 is 4, Y1 is -3. X2 is -4, Y2 is 3. On this table, X1 is Y. X1 is 1, Y1 is 3, X2 is 5, Y2 is -1. Now it's important to note that these are 3 individual sets of data. These represent 3 different functions. That's why I have this line here. They represent 3 different functions. Now, the first step is to identify the variables. Well, we can't find the variables yet. This gives us the 2 points on the graph. So the next step that we can do is solve for slope. Remember, to solve for slope, it is y2 minus y1, the change in y. So taking each of these sets of information, we're going to plug it into this scenario or this formula to solve for slope. We find slope, or m, by doing y2 minus y1 over x2 minus x1. So what does that look like? So for the first one, it is y2 minus y1, and I'm going to pause something just to make sure I have that correct. All right, so I had made a mistake here. I had mixed up the X and the Y in this first tile. So let's go back to my cool image here. So, oops, made a mistake. So y2 minus y1 over x2 minus x1. So 1 minus -2 is 3. These two cancel out. So it's when they say don't never do something, that's the double negative. Don't never do something inherently means go ahead and do it. So just in case, hey Siri, what is 1 minus -2?
It's 3.
All right. And 1 minus 3 is -2. So we now know that the slope is 3 minus 2. I'm just going to hold on to that information for a second while I come up here and I do the second one. Again, y2 minus y1 over x2 minus x1. So, and I tried to keep them in a line here. So we've got y2, which is 3, minus y1, which is minus 3, over x2 minus x1. So we get 3 minus negative 3. Again, those cancel out. And then negative 4 minus 4. Now, let me check something again, make sure I'm leading you right. Okay, yes, I was correct. 3 minus negative 3 is 6. Negative 4 minus 4 is negative 8. We reduce that. So slope equals negative 3 over 4. Okay, again, we're going to hold on to that one for a second while we do this last one. So the last one is negative 1 minus 3. So negative 1 minus 3 over 5 minus 1. 5 minus 1. That leaves us negative 1 minus 3 is negative 4. Over 5 minus 1 is 4. We do the math on that to reduce it because 4 over 4 is 1, but we have that negative sign, so it's negative 1. So taking that information, those three numbers, and looking back at what slope those would represent. So we're going to I'm going to try to minimize this here and see if it works for us. Okay. So yes, it works, but it's really hard to see. Okay, how's that? So now what we have to do is look at these slopes and see what is matching here, here, and here. So that's why some of these problems are so complicated, because of all the different steps. That's why if you have an issue or a concern, you need to raise your hand, get a hold of us, write us an email, send a homing pigeon, say, I don't understand. Because every single one of these steps adds up to a correct answer. And if you can't follow the steps, then we get lost. And none of this part makes sense. So we have 3 over 2 with a negative sign. I see a 3 over negative 2 with a minus sign there, or a negative sign. None of these have that same slope. So I'm going to go to the pair that had, so this is the pair that had the 3 over negative 2. So I'm going to put that there. Now, the next one is negative 3, 4. So I see right away negative 3, 4. So I'm going to put that one right here. The one that says 3, the initial numbers were 4, negative 3, and negative 4, 3 goes here. So the second tile goes at the bottom. Well, of course, that makes our last tile pretty easy. But just so we're clear, that last tile was represented by a -1. Well, when we have -1, we drop the 1 because we don't say we have -1x, because 1 times anything is itself. So we just leave it as itself, or negative times the x. So that's how we got that one. And this isn't on your guided notes, but this is exactly the steps that goes into solving one of these problems. All right, moving on.
Linear functions can be described with verbal descriptions, tables, graphs, or even just 2 points. We can create equations for linear functions described in any of these ways. For example, we used a verbal description to find the function that represents Vicky's phone battery life in terms of hours off the charger. There are 3 elements to figure out when creating the equations. First, determine the independent and dependent quantities. Next, find the rate of change. Finally, find the initial value. After completing these 3 steps, we can substitute the values to create the function's equation. It's also important to be able to interpret a function in terms of the given situation. We did that with the function representing the amount of water in the cat's water bowl. We can also create an equation and interpret a function represented in a graph. For example, we interpreted the graph representing a plumber's charges for fixing a clogged kitchen drain. We can even create a function when given only 2 points represented by coordinates or values in a table.
All right. That was very helpful summary there. Congratulations, you've completed the tutorial constructing and interpreting functions, and I was able to get it in under an hour. Woohoo! All right, here we go. Have a great time.